Page 112. Temperature scales, heat, and thermal energy transfer. Recap, Section A. Molecules of all substances, regardless of the phase of matter they are in constant motion and have kinetic energy. Temperature is the measure of the average kinetic energy of the molecules in a substance. A thermometer is used to measure temperature. Scientists use two temperature scales. This Celsius temperature scale is divided into equal parts called degrees. On the Celsius scale, the freezing point of water is 0 degrees Celsius, and water boils at 100 degrees Celsius at sea level. The Kelvin scale temperature is the official SI temperature scale, and is divided into equal units called kelvins, which is noted with a capital K. The distance between intervals of the Kelvin scale are identical to those of the Celsius scale. To convert from degrees Celsius to kelvins, add 273. Freezing point of water, since it is 0 degrees Celsius, if we add 273, it should be 273 degrees Kelvin. This right here is a typo in our book. It should be 273 degrees Kelvin. Room temperature, which is 20 degrees Celsius, if we add 273 to it to convert it, the room temperature in kelvins is 293 degrees Kelvin, and this is correct. The lowest point on the Kelvin scale is 0 kelvins, also called absolute zero. This is the theoretical point at which all molecular motion stops. Section B, thermal energy. Thermal energy is the total energy of the particles that make up a substance. The amount of thermal energy in a substance depends on both the average kinetic energy of its molecules, which is temperature, and the amount and kind of molecules in the substance. Section C. Heat is the transfer of thermal energy from a substance of higher temperature to a substance of lower temperature. So heat travels from high to low. When two substances at different temperatures come into contact, their molecules will gain or lose energy until they reach thermal equilibrium. At equilibrium, both substances have the same temperature because of the average kinetic energy of their molecules is equal. Section D. A phase change is a physical change that may take place as thermal energy is added or removed from a substance. A phase change occurs at a specific temperature for any pure type of matter. The temperature of a substance changes as the average kinetic energy of its molecules change. Refer to the graph to the right that shows the addition of thermal energy to water. At 20 degrees Celsius, water is in its liquid state. As thermal energy is added, the average kinetic energy of the water molecules increase, and the temperature rises for 5 minutes. After this, the temperature stays the same because the liquid water is becoming gas. So the flat part of our graph is when we have a phase change. The temperature of a substance does not change during a phase change. When water reaches its boiling point at 100 degrees Celsius and thermal energy continues to be added, the temperature of the water remains at 100 degrees Celsius. This is illustrated by the plateau or flat line on the graph above. During this period, the thermal energy added to the water is being used to break the attraction between the polar water molecules. The physical arrangement of the molecules is changed, and the increased distance between molecules allows a phase change. In this case, it's vaporization. There will be no increase in temperature until all the water has changed to water vapor. Likewise, there is no temperature change when thermal energy is added to a solid at its melting point. When ice at 0 degrees Celsius absorbs thermal energy, its temperature will not increase until the ice has changed to water. There is also no temperature change when a gas loses thermal energy and changes to a liquid. such as water vapor condensing to become liquid water, or when a liquid loses thermal energy and changes to a solid, such as when liquid water freezes to become ice. Section E. Thermal energy is transferred in 3 ways. The first method of transfer is conduction. Conduction is the transfer of thermal energy from warmer matter to colder matter, with which it is in direct contact. Energy is transferred as vibrating molecules collide with one another. An example is a pot in contact with a hot stove. That pot will get hot because it is in direct contact. This is conduction. Convection is the transfer of thermal energy by the movement of molecules within a fluid, liquid or gas. Particles move from place to place and carry energy with them. Usually, when a fluid is heated, it expands, becomes less dense, and rises. The colder fluid sinks because it is denser. These rougher circular patterns of movement are called convection currents. Example: the air near a fire gets warmer and less dense, so it rises and is replaced by cold air. So in this picture, here's the fire. The warm air is going to rise until it cools. Once it cools, it's going to sink again in this circular pattern. The third method of transfer is radiation. Radiation is the transmission of energy in the form of electromagnetic radiation. This type of energy transfer does not require matter. Electromagnetic radiation imparts energy to the molecules of a substance, causing them to collide with other molecules. This friction causes the temperature of the substance to increase. For example, the sun gives off several types of radiation, including visible light and infrared waves. So the sun is radiating and it's transferring energy to the earth. Section F. There are many practical everyday applications of the principle of thermal energy transfer. Heat engines use thermal energy produced by burning a fuel to move something, to do work. Examples of heat engines include diesel engine and the gasoline engine in an automobile. Some older thermostats have bimetallic strip. The two metals expand at different rates when they gain thermal energy. As the strip is heated or cooled, it coils or uncoils, which completes or interrupts an electric current that turns on or off the thermostat. Refrigerators and heat pumps move a refrigerant, a chemical that readily absorbs thermal energy, from an area of high temperature to an area of lower temperature, allowing the heating or cooling of an interior space. A geothermal system is a central heating and/or cooling system that transfers thermal energy to or from the ground. The core of the system is a loop through which a liquid refrigerant is pumped. As the refrigerant circulates through the loop, it absorbs and removes thermal energy from the space to be cooled and transfers the energy to a different location. The Earth is a source of thermal energy during cold weather or a thermal energy storage location during hot weather. This ends the temperature, scales, heat, and thermal energy transfer section.